This is section 5.5, trapezoids. So we begin with the definition of a trapezoid. A quadrilateral with exactly one pair of parallel sides is called a trapezoid. So it only has one pair of parallel sides. It's a quadrilateral, so it still has four sides, but one pair of opposite sides are parallel. So this purple picture I've drawn on the right is a trapezoid. The top and the bottom are parallel, and I know that because of these arrows that I have right here. The other two sides are clearly not parallel, because if I were to extend the left side, it's eventually going to run into the right side. The parallel sides of the trapezoid are called the bases. The other sides, the ones that are not parallel, are called legs. A trapezoid with congruent legs is called an isosceles trapezoid. So this lime green trapezoid I've drawn here has its legs congruent, which I know because I see these hash marks here. So it is an isosceles trapezoid. Are trapezoids parallelograms? Absolutely not. You should be yelling that at your screen. No, they are not parallelograms. It's impossible for them to be parallelograms because they only have one pair of opposite sides parallel. They do not have two pairs. So they cannot, by definition, be parallelograms. Don't confuse trapezoids with parallelograms. They are all quadrilaterals, but not all quadrilaterals are parallelograms. Quadrilateral just means it has four sides. We have two theorems about trapezoids. First theorem says base angles of an isosceles trapezoid are congruent. Base angles are the angles made by a leg and a base. So in this red trapezoid I have here, one pair of base angles would be angle B and angle A, and another pair of base angles would be angle X and angle Y. So what this theorem says is angle B is congruent to angle A, and separately angle X is congruent to angle Y. We're not going to write down a formal proof of this, but we're going to talk through it. The way we would need to do it is to draw in some auxiliary lines, some lines that are not currently drawn, but that will help us to prove what we want to prove. And the lines I'm going to draw, there's a couple ways you could do this, but here's how I would do it. Is I'm going to draw a perpendicular line from B and from A. So these are perpendicular. And doing that gives me two triangles, one on the left side and one on the right side. In those triangles I have right angles, I have the hypotenuses are equal, and if I can get those two triangles congruent, then I would know that angle X is congruent to angle Y, which is what I want to show. So what could I have to do to get those two triangles congruent? Well, I've got right angles and I've got the hypotenuses. Do I know a pair of legs? Let me label this point as P and this point as Q. And I know from a theorem that we just did in the previous section that BP has to be congruent to AQ, because whenever you have parallel lines, the points on one line are equidistant from the points on the other line. So the distance from B to P has to be the same as the distance from A to Q, because BA is parallel to XY. That was a theorem we just had in section 5.3. So that gives me that triangle XBP is congruent to triangle YAQ by HL, and so angle X is congruent to angle Y by CPCTC. How would I get angle B congruent to angle A? Because that's the other piece I need to show. That's the other pair of base angles. Well, these congruent triangles would get me part of those angles, angle XBP and angle YAQ. I actually know that angle PBA and angle QAB have to be right angles because this turns out to be a rectangle in the middle. So by the angle addition postulate I can add those two congruent parts together and get that the whole parts are congruent. So that's just a brief sketch of what that proof would look like. One more definition. A median of a trapezoid is a segment that joins the midpoints of the legs. So it cuts straight across the trapezoid, joining the midpoints of the two legs. Since there's only one pair of legs, and each leg only has one midpoint, there is only one median for every trapezoid, which is different from a triangle. Triangles had 3 medians. In a trapezoid, there is one median. It's the segment that joins the midpoints of the legs. So in this picture, MN is the median of trapezoid SRQP, because M is the midpoint of SP and N is the midpoint of RQ. Now that we know what a median of a trapezoid is, here's a theorem about the median of a trapezoid. This theorem has 2 conclusions. First, the median of the trapezoid is parallel to the base, to each of the bases of the trapezoid, parallel to the bases. And second, the median of a trapezoid is equal in length to the average of the base lengths. Average something means we add them up and we divide by the number of them we have. So the average of the bases will be to add up the 2 base lengths and then divide them by 2. So I've drawn a trapezoid in purple here. SRQP is my trapezoid. I've drawn the median, MN. And then I've drawn some extra lines, some auxiliary lines, to help me work through the proof of this. And again, I'm just going to talk through it, maybe write down a couple of the key steps, but we're not going to write a full proof. The reason I've drawn, what I drew was I drew SN and extended it, extended PQ to the right, and then found the point where those 2 lines met and called that point T. Doing that gave me this triangle. That triangle should look familiar from section 5.3, where you have a segment that joins the midpoints of 2 sides of a triangle. And we had a theorem that said the segment that joins the midpoints of 2 sides of a triangle is parallel to the 3rd side. So by that theorem, MN is parallel to PQ because MN joins the midpoints, not joins the midpoints, MN, yes, joins the midpoints of 2 sides of triangle STP. So that tells me MN is parallel to one of the bases. How do I know it's parallel to the other base, SR? Because by a trapezoid, PQ is parallel to SR. So PQ is parallel to SR. That's the definition of a trapezoid, that the bases are parallel. So with a little transitive, I know MN must be parallel to SR, which proves that the median is parallel to the bases. How do I prove that the median is equal in length to the average of the base lengths? Well, the other part of the theorem that tells me MN is parallel to PQ is that when a segment joins the midpoints of 2 sides of a triangle, not only is it parallel to the 3rd side, but it's half as long as the 3rd side. So MN, let me write this in a different color, MN must be half of PT but PT is PQ plus QT, so it's half of PQ plus QT. Segment addition postulate tells me that PT is PQ plus QT. And I can prove triangle SRN is congruent to triangle TQN. So QT is congruent to SR, and I'm going to use that and substitute it in here to get that MN is half of PQ plus SR, which means it's the average of PQ and SR. If we add up PQ plus SR and divide by 2, that's the average of PQ and SR. So MN is equal to the length of the average of the base lengths, equal in length to the average of the base lengths. So you're going to take this theorem and we're going to use it to solve this example problem. Find the value of x in the trapezoid. So the whole thing I've drawn is a trapezoid, and then I drew the median of the trapezoid. And I can tell it's the median because those are equal, so this is the midpoint of the top side, and those are equal, so this is the midpoint of the bottom side. So I know the median of the trapezoid is equal in length to the average of the base lengths. If I'm going to take the average of the bases, I'm going to take x minus 3 plus 2x minus 4, and there's just 2 of them, so when I take the average I divide by 2. That needs to be equal to the median, which is 10. So I can set up this equation. And now I'm going to solve this equation for x. Well, I can get rid of that 2 if I multiply both sides by 2. So that's same as saying 20 equals x minus 3 plus 2x minus 4. And I can drop the parentheses because I'm just adding between them, I'm not multiplying. So 20 equals x plus 2x is 3x, negative 3 minus 4 is negative 7. Add 7 to both sides. 27 equals 3x, divide both sides by 3, and x equals 9. So the only difficult part is making sure you set up the equation correctly. You take the average of the bases, which means you're going to add them up and divide by 2, and set that equal to the median. Okay, now try your immediate practice problems. Trapezoid DCBA is isosceles, which means DA is congruent to CB, and EF is a median of the trapezoid. In your notes, draw the diagram, and then copy and complete each statement. Number 1, if AB equals 25, and DC equals 13, so if AB is 25 and DC equals 13, find the length of the median EF. Use the fact that the median is equal to the average of the bases. And then, number 2, if angle A is 50 degrees, find angle B and find angle D. Using the fact that DC is parallel to AB, you have same side interior angles, which must be supplementary. That is the end of section 5.5.